and welcome back to Common Core Algebra 2. This is the Unit 2 review of functions. What I think you should do here is really take a look at each problem before you listen to my explanation of it, so that way you know you're giving yourself a chance to, think and come up with the right answer. So, again, I'm going to just move on from 1 to 2 to 3, but it's my suggestion that you're pausing before each question to try it on your own. Make sure that when you're doing these, you're annotating. Make sure you're underlining the important words, boxing in the mathematics. That's so important because the words are what messes you up, because they're what messed me up. All right, so we're going to start now with number 1. So you should pause before I continue. Hint, hint. So 1, which of the following sets of ordered pairs would not be considered a function? Would not be considered a function. So what I'm thinking about is a function. I know a function cannot have repeating x values. So as I'm looking here, I'm looking for my x value. So here, that number 1 is a function. Looking here, look here. This is not a function, but just to be sure, I'm going to just double check the rest of them and make sure that they're not functions. Now remember, the y's can repeat just to be a function. They cannot repeat to be a one-to-one function. So the answer here is number 2. Number 2, in the following graph, the height of an object in feet is given by the function of time in seconds. Which of the following would be the range of the function? Well, the range is the key word here, so we know that's going to be the y values. So we know the y values go between the highest point and the lowest point. And the lowest point here is 0. That's my lower bound. So looking at my examples, I know I can get rid of 3 right away. And the upper bound here is, remember, the second number is going to be my y. So between 576. So the correct answer would be 4. Number 3, in which of the following 4 graphs is the output not a function of the input? So we're looking for something that's not a function. So once again, I'm going to remind you about the vertical line test. So if we look here, we can see how the first one is a function because it does not hit that function, that graph or that relationship in more than one spot. All right, when you get to number 3, this one's a function, everything's great there. Number 4, this one's a function, and when we get to number 2, nope, not a function, it hits in 2 spots. So my correct answer is number 2. Number 4, if f of x equals negative 1/2 x plus 6, then which of the following values solves the equation f of x equals 10? So what that's giving us, be careful here, because what they're giving us is they're asking us what the x is when y is 10. So plugging it in, we have f of x is equal to negative 1/2 x plus 6. So you get 10 equals negative 1/2 x plus 6. And when we solve this, subtract 6, you get negative 1/2 x is equal to 4. Multiply both sides by 2 over 1, negative 2 over 1. And x is equal to negative 8. Going on to number 5, the function f is defined by the formula f of x equals x squared plus 2, and the function g is defined by the graph shown below. Which of the following is the value of f of g of 2? So they're telling us f of x is this, and g of x is the graph. So the first thing we're going to evaluate is f of 2. So when x is 2, y is 4. So now we're going to find what's f of 4. This means substituting into our function, which is 4 squared plus 2, which is 16 plus 2, which is equal to 18, number 1. Number 6, given the function f of x shown in the graph below, for which of the following intervals is f of x greater than 0? What this basically means is where y is positive. So for what interval of x is y positive? So y is positive between this point and this point, inclusive. 1, 2, 3, 4, between negative 4, 1, 2, 3, 4, 5, 6, between negative 4 and positive 6, inclusive. That means square brackets. 7. Which of the following values of x would not be in the domain of the function? Look for the restrictions. We have a fraction here, so we have 2x plus 5 must not equal 0. So what value is that? 2x cannot equal negative 5. Divide both sides by 2, and negative 5 halves, which is the same thing as negative 2 1/2. If the point 4, negative 2 lies on the graph, y equals f of x, then which of the following points must lie on the graph of its inverse? So I'm going to remind you, if we had the point 4, negative 2 to be in the inverse, we simply flip them. So negative 2, comma 4. 9. Which of the following graphs represents a one-to-one function? Once again, we have to ask ourselves which one is a function first. So if we take a look here, 1 is a function, 3 is a function, 4 is a function, 2 is not a function, so obviously it cannot be a one-to-one function if it's not even a function. So consider now the one-to-one test, which is basically the horizontal line test. So 1 is not a one-to-one function, neither is 3. Obviously 2 was not a function, so we don't even need to test that one. So the correct answer is going to be number 4. 10. Given the function shown below, over which of the following intervals is a function always increasing? So always increasing. Well, if you look here, it decreases here to get until the point it gets to this point here. Then it's increasing from here to here, and then it stops, and then it decreases again between here and here. So if we take a look at what interval it's always increasing, it will be between, interval means x values, so between here and here, 3, 4, 5, negative 5 and positive 2. Negative 5 and positive 2. Notice there's no equal sign there because at that point it's not increasing nor is it decreasing at negative 5 and 2. Going to piecewise functions. Which of the following is the y-intercept of the piecewise function defined as g of x equals? So we're looking for, remember what the y-intercept means. The y-intercept means when x is 0, y is a number. So what are we looking for? We're looking for where x is 0, which means it has to be this one we're using. So we're going to put 0 minus 3 squared minus 1, which is negative 3 squared minus 1, which is positive 9 minus 1, which is 8. 12. Given the function y equals f of x shown graph below, answer the following questions. State the value of f of 2. Going to remind you this means x is equal to 2. So when x is 2, what is the y associated with that? And the answer is 4. So f of 2 is equal to 4. How many values solve the equation f of x equals 5? So remember, when y is equal to 5, so where is the line y equals 5? 2, 3, 4, 5. It's right here. So it's not asking for the actual values, it's asking how many values. And the answer is 1, 2, 3. 3 values. And it says to explain how you arrived at your answer. This is where you may say something along the lines of, when I draw the line y equals 5, that line intersects the function in 3 spots. 1 to the left of 0 and 2 to the right. And that would be written. On the interval between 0 and 4, what is the function, is the function increasing or decreasing? So between 0 and 4, the function goes from here to here. It is most definitely decreasing. The function is decreasing. And here you would explain, because, I'm not going to write this all out, but you would say something like it's heading downward between the x value of 0 and the x value of 4. If a second function is defined by the formula g of x equals 2x minus 7 divided by 3, then what is the value of g of f of 1? So again, we're going to make sure we start with f of 1 on our graph. So f of 1 is 1, 2, 3, 4, 5, 6. It happens actually right there. That's 6. And now I have to do g of 6, which is 2 times 6 minus 7 divided by 3, which is 12 minus 7 over 3, which is 5 over 3. Don't worry that it's a fraction. And would the inverse of this function also be a function? Yes or no? So the first thing I'm going to look for is to see it is definitely a function. It passes the vertical line test. But because it does not pass the horizontal line test, I know this original function f is not a one-to-one function. So very important, star, star, star here. Would the inverse of this function also be a function? You'd explain your answer, and you would write here, no, the inverse would not be a function because the original function f is not a one-to-one function. That is the answer that they're looking for. And for the function f of x equals the square root of x minus 9, either x equals 0 or x equals 45 is a member of the domain. Determine which and explain how you arrived at your answer. Well, simply show this. So when f of 0 is equal to the square root of 0 minus 9, which is the square root of negative 9, which we know is not allowed. You cannot have a negative underneath a radical sign. And then the next one is f of 45, which is the square root of 45 minus 9, which is the square root of 36, and the square root of 36 is 6, and this is a member of the domain. The part where it says explain, you would make sure you write in words how f of 0 turns out to be a negative number and that you cannot have a negative under the radical. 14, is the function y equals absolute value x minus 6 plus 2 a one-to-one function? Explain your answer. Now, the best thing to do here is show a table of values. X, y. Show a table of values and show where the function definitely will change. So what you would do at this point is you could pull up your calculator. And once you did that, you can see very easily how our y's repeat in this situation. So this is not a one-to-one function, and you would write here, y inverse is not a one-to-one function. And you need the word, of course, when it says explain, you need the word because. And you can say, as you can see in the table, the y values repeat for 5 and 7, and then again for 4 and 8. Showing a table of values is always the best way to show if something and explain that something is not a one-to-one function. 15, given the function y equals f of x shown below, do the following. Graph the function's inverse. Now, using a table of values is really kind of the best way to do this. So x and y. So the point that we have here, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 5. So this is negative 7, negative 5. This point is 1, 3. And this point is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. So 7, 5. So in order to graph the inverse, we're just going to flip them. So negative 5, negative 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 3, 1, 2, 3, positive 1. And 7, 4, 5, 6, 7, positive, I'm sorry, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So this is going to be the inverse. State the range of the inverse. Well, the range, you can either look for the domain of the original one or the range of our new green one. So 1, 2, 3, 4, 5, 6, 7. This is negative 7. This is positive 7. So it doesn't tell us how to state the range. So why don't we, if we were going to use set builder notation, it would be y such that negative 7 less than or equal to y, which is less than or equal to positive 7, or you could use interval notation as negative 7, 7. What is the value of f inverse negative 3? So you can do one of two things. You can think about the points as x comma negative 3 on our original function, or you can look at the green function and look at where negative 3 is. Negative 3 is 1, 2, 3. Go down, which is this point right here. 1, 2, 3, 4, 5, which is negative 5. The temperature of a room is measured over the span of a day with selected values given in the table below. Based on this table, so we take a minute and just take a look and say at time, at 0.5 it's 64, at 1.5 it's 66, so it's definitely going up. Based on this table, explain why temperature can be considered a function of time, but not can be considered a function of temperature. Well, if we look here, so the function of time is fine, but what happens to temperature? Temperatures will probably be, yep, here they are. Temperature will repeat. So it cannot be a function of, so this would not be a one-to-one function. Anything else repeating? 79, 78, nope. So that's what you would explain, that the time does not repeat, but the temperature does. So remember to look at these again, study, and we'll go over them in class. Bring your questions. Have a good one.